Hi everyone, let's solve this problem linked list components. So the problem statement says we are given this linked list 0, 1, 2, 3 and a list G which has subset of values from this linked list which is 0, 1, 3. All we need to return is total number of connected components. So what's the definition of a connected component? So the values of G, right, which are appearing consecutively inside this linked list forms a connected component. So for example 0, 1, these both values are appearing in this list G, right? So this is forming a single connected component. This is not a connected component because it's separating this component with this guy. So this is a single connected component of length 1. So let's see how we can solve this. There are two techniques to solve this problem. One is this event trigger algorithm. What it says is the moment I see my event, something happened, right, I take some action. So the another one is event termination algorithm, where we say, okay, if something finishes, let's take some action. So we'll solve with first with this event trigger algorithm. Let's see how we can solve it, and then we'll jump to the event termination algorithm. So let's first convert this G list to G set, because it's easy to check if this element exists inside the set rather than in the list. So all I say is my total components, right, are 0, and while I'll start iterating from left to right. I say, okay, if head dot val is inside G set, right, it means, oh, this value was inside G set, and in this case something triggered now. So what happens? Okay, I found the first value while iterating. I found that value was inside G. So what I'll do, I will process this event. How can I process this? I say, okay, total number of connected components now increments by 1, but now let's reach at the place where the value is not inside the G, right? So let's do that. I say, okay, my total components will be incremented, and I ask for new head. So okay, self, give me new head. And what is my head now? I'll pass it head and G set, and it will give me a new head where the value will not be inside the set G. Otherwise I'll take my head to next position. Once I'm done, I just return the total components. So let's write this function give me new head. So I say, okay, so if you have to give me new head, take this head, take this G set. All you need to do is check if you exist, and head dot, and while head dot val is inside G set, I keep moving, right? So once I'm done, either I'll be null or my value is not inside the G set, which is what I wanted, right? So let's see guys if it works. Okay, let's submit it. Awesome, it does. So let's jump to this event termination algorithm. So in event termination algorithm, let's get rid of this setup first. So what you say is, okay, we don't need this guy, and maybe we need this loop and total component, right? So this is what we want. So all I'm trying to say now is the moment my event will finish. So what is the event finish? Okay, if I find my value is inside the G set, right, which is like 1 was inside this G set, but its next value should not be inside the G set, then I'll make a count. And probably if next element is also null, then again my event finished, right? So I just keep making that count. So let's see how we can write this setup. I say, okay, if head dot val is inside G set, I just need to see, does this end here, like, is event end, right? If it says yes, right, all I need to do is I need to count my total number of components, and I just keep moving, which I have to do every time. So this is what the setup is. So let's write this function. I say, okay, in order to find if this event ends, right? So this is my G set. Sorry about this. So all I say is, okay, if not head dot next, right, I will return yes, it is end of the list, right? If not head dot next dot val in G set, right, again I will return true. Otherwise I just return false, right? So we can just keep it in a single condition also, but I think this makes much sense. Let's see guys if it works. Let's submit it. Awesome, it does. See you guys in next video.